Hey there, biology students, and welcome to our little video here reviewing the water quiz. Okay, so for you students that do not have me in class today, check this bad boy out. This is me walking you through the water quiz and in turn going through the water lab and those 4 little mini demonstrations that you would have completed in the properties of water lab. If I do not have your properties of water lab yet, get it turned into the substitute teacher. Okay, that way I can go ahead and gather that, grade that, and get you some feedback on that. If you don't have the quiz done yet, do the quiz. Then watch this video, grade yourself, check yourself, make sure that you are good with all the information. Okay? So let me pull it up here on the website. Nemaha Valley Science, Unit 3 page, The Chemistry of Life. We'll scroll on down here. Water formative quiz. Alrighty. First question. Draw a diagram that shows why water is considered a polar molecule. You should have something that resembles what I'm going to have on the board up here. So our oxygen atom, our 2 hydrogen atoms, and those electrons that are part of that hydrogen atom, because of the 8 positive charges inside of this oxygen atom's nucleus, these electrons are pulled a little closer to that area. So if we were to draw a midline between this molecule, we would have more electrons towards the oxygen atom than the hydrogen atoms, therefore giving us 10 negative charges in this area to 8 positive charges, and giving us 2 positive charges to 0 negative charges in this area, making water that little magnet that I spoke about in the original video. Okay? So it's a polar molecule. It's got a slightly positively charged area or end and a slightly negatively charged area or end. Okay? So your diagram for how water is a polar molecule needs to look like that. Something along those lines. Number 2, due to water's polarity, it can exhibit several specific features or traits. List the 4 and describe. This is where the properties of water lab comes in. Your first one was to just take a little pipette, draw some water out of the beaker, and then drop it onto the table. I want you to talk about and draw and observe the shape of water. Okay? Yes, it's a fluid. It fills its container. All right? It takes the shape of its container. But because of its polarity, it makes that little dome, that little semicircle shape. Okay, that's what I wanted you guys to talk about. It just doesn't flatten out on the table and only is 1 water molecule tall across the table. If that makes sense. You've got water molecules stacked on top of water molecules, and they all kind of stay together in that little semicircle, that droplet shape, because of water's polarity. All right, so water has a special shape even when it's not necessarily inside of a container to a large volume because of the polarity. The second little demonstration talked about cohesion and adhesion, 2 of the other 4 properties here. Okay, I guess the first one also talked about cohesion, but the second activity also talked about cohesion, but it brought in adhesion with the penny. And you took the dropper and you saw how many water droplets you could get on top of the penny. So these water molecules were adhering to the penny. All right. Water attracted to other polar molecules that aren't water, so adhering to the penny, and then the water molecules were cohering to themselves. Some of you, if you looked at that penny closely and you got a lot of drops on there, you would have seen that the actual height of the water was greater than that of the penny, and also may have been bulging and hanging over the sides. All right? So you would have demonstrated to yourself water's cohesive and adhesive powers. All right? The third little demonstration talked about surface tension. Okay, so that's the third of our 4 traits, special traits here. We've got cohesion, adhesion, now surface tension. And you would have tried to take the little paper clip and set it right on top of the water inside of your beaker. You would have seen that the water surface actually bulged underneath, kind of like slid underneath it. This paper clip was never in the water. It was just sitting on top. Because of the polarity of the molecules on top and gravity helping to hold them down, water has a certain amount of tension on the top. It's got a tight top. So it can hold a certain amount of mass and a certain amount of force can be placed on it without that actual surface breaking apart. DJ Weichert brought up a good example about that's why it hurts when you belly flop. Because when you actually belly flop, you're spreading your mass over that greater amount of surface area, and just for a fraction of a second, you're hitting the water, and that surface is not breaking. So you're just hitting the ground, hitting a solid object almost. Okay. The fourth one dealt with capillary action, which is cohesion and adhesion working together. You were to take your strip of filter paper or paper towel, porous material, and just wanted you to submerge the very tip of that paper towel in the water, and you should have watched the water travel vertically, defy the laws of gravity and travel vertically. What was going on? Cohesion and adhesion. The water was adhering to the materials inside of this paper towel, and it was cohering to itself as it traveled vertically. Okay? Cohesion and adhesion again. So a little review there with the properties of water lab and answering question number 2. Water's 4 special traits because of its amazing ability as a polar molecule. Number 3 talks a lot about solvents, solutes, solutions, and water is a universal solvent. A solvent is any type of material that can break other materials down physically. So for instance, a liquid, and you may dissolve something inside of that liquid, so that liquid is a solvent. Okay, it's physically breaking down another material, whether it be a liquid or a solid. A solute is the material that's being broken down or is dissolving. So the example I think I gave in the video was about Kool-Aid, where water is the solvent and the sugar is the solute. A solution is a solvent and a solute put together. Okay, a solvent and a solute put together gives you a solution. Okay, so Kool-Aid would be the solution. We get into a little bit of what we call saturation, a term used to describe the level of solute inside of a solvent, or solute inside of a solution. Kool-Aid made to the packet's specifications, so 2 cups of sugar, would be saturated. If you put in an extra cup of sugar, that sugar wouldn't dissolve inside of the solvent. It would be super saturated. And if you only went with 1 cup of sugar, it would be unsaturated. All right. Water is a universal solvent because of its polarity. Because of those little magnets, it can break and reform hydrogen bonds really, really easy with other polar molecules and physically break them down, make them smaller and smaller and smaller and smaller and smaller. Number 4 talks about pH. Your book's got a fantastic little diagram showing you some household items, common everyday items, and what their potential hydrogen ion concentration may be. The 2 blanks there, due to water's polarity, it can react with acids and bases and adjust their strength. So water is what we call a buffer when we start talking about how it can dilute, all right, or be a solvent for acids and bases. Towards the 0 end, you need to have the word acid or acidic, and you also need to have more H plus ions, hydrogen ions. Towards number 14, you need to have basic, and you need to have more hydroxide ions. That's what that OH minus means. And 7 is neutral. That's where water resides. We'll talk a little bit more about pH as we go over the next couple of units, but we're basically talking about the amount of hydrogen ions or hydroxide ions inside of a solution, inside of a liquid, inside of a material, and that gives us an indication on how reactive that material may be. Okay? How reactive it may be. Water does a good job of, because of its polarity, those molecules bonding with physically and then chemically reacting with some of the hydrogen ions and hydroxide ions to dilute or bring those extreme acids or bases closer to the center where it's more neutral. So it takes strong acids and bases and can make them weak acids and bases, hence why we call water a buffer solution. Number 5, water strider. How can it skate along the top of the pond? It's because of D, the high surface tension. A substance that minimizes the changes in concentration, so it slowly dilutes it, is what that question's kind of saying. What substance slowly takes a strong acid or a strong base and makes it a weak acid or weak base? That's C, a buffer. Why does water move from the roots to the leaves of plants? Capillary action. Okay, capillary action. All right, that'd be B. 7. Why can water have no net charge but slight charges in different parts of the molecule? That's basically the definition of polarity. So A, the oxygen in is slightly negative, and the hydrogen in is slightly positive. 9, we saw that in number 7. That's B, capillary action. And then water's pH, number 10, is C, 7. That's it for the quiz. We, again, in class, with those of you that don't have me in class today, we will answer any questions that may have over this, okay? You got to initiate it, all right? You got to initiate it. Here's me going over it with you. You got to initiate this question. I would love to make sure that we all understand this, but you got to initiate that for me, all right? Let me know if you have any questions. Adios.